Hey everybody, this video will talk about solving a polynomial inequality problem type 2. This is very similar to problem type 1. The only difference is sometimes we have a squared term, which is fine because the squared term means that that bit is always going to be positive because anything squared is positive. So these ones are actually kind of a little simpler, but you can definitely go watch other videos if you need more help understanding this concept. But remember, we're going to check wherever my polynomial is equal to 0. And that happens where each of my factors is equal to 0, which is going to be at x equals -5 and -2. So those are like my critical points to check. But I don't want my function to be equal to 0, I only want it to be greater than 0. So remember, that's where my function is above the x-axis, the outputs where my function is above the x-axis. So at -2 and at -5, I'm going to have an open circle. Remember, if there's an equal to sign, then I'm going to have a closed circle. Okay, and I'll show you the difference at the end of this video. So now, in between each of these intervals, I need to test some points. The points I test are going to be separated by my 2 points, -5 and -2. So let's go ahead and test the x value, -8. If I plug in -8 for x, -8 plus 5 squared is -3 squared, but that's always going to be positive because it's a squared term. And then -8 plus 2 is a positive as well. So this interval from -infinity to -5, I have a positive, which means that my function is above the x-axis. If I plug in -3, again, -3 plus 5 squared, that's always going to be positive. And then I have -3 plus 2, which is a negative. So between these two values, I'm going to have a negative outputs. And then let's go ahead and test 4 because it's over here and I have some room. So 4 plus 5 squared times 4 plus 2. This term is positive and this term is positive. So overall, my function is going to be positive. My function outputs are positive there. And that's what I wanted. I wanted intervals where my function outputs, or this bit, which is my function, I wanted intervals where my function outputs were more than zeros. So that happens from -infinity to 5, and then from -2 to infinity. And it would look like this on the number line. So any x value that I plug in between -infinity and 5, and then from -2 to infinity, will give me outputs that are greater than 0. Now let's go ahead and say that we change this a little bit, and we say, hey, let's let it equal to 0. Let it be more than 0 and equal to 0. What would that look like? Well, it would be the same, but at -5 and -2 we would have filled in circles. But then our intervals would be the same, like this. So what would that look like? Well, we'd go from -infinity to 5, and then we'd go from -2, except for we need to include -2. I included -5. We go -2 to infinity. And I also noticed here that it didn't include my negatives. Always remember to check your signs on your work, okay? So the difference between an equal sign and not an equal sign is that I'm going to include or not include those endpoints.